So let's do from the part 1 section, we're going to do problem number 2 and problem 33. So let me cut here the instructions so that we have them to refer to. So it says, the given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trig functions of theta. Okay? So the first thing you're going to do is draw yourself an xy axis. You're going to find the point negative 6, 6. You're going to put a dot there. Okay? The next thing you're going to do is you're going to connect to the origin, and then you're going to connect to the x-axis, always in that order. Take the point, connect it to the origin, then take that point and connect it to the x-axis. You can even put a little right triangle mark right there. And then our theta is this reference angle right here that is closest to the origin tucked in that triangle. Now let's label the sides that we know. Now, normally a triangle, the sides are always positive. But in this case, we have some negatives because of the fact that we have some directional aspects to it. So this is negative 6, and this is positive 6. Now, the hypotenuse of this triangle will always be positive. If you've watched the video already, we call that hypotenuse our radius, our r. Okay? And so let's calculate that. So we know that 6 squared plus negative 6 squared, and use parentheses, is going to equal our r squared. So our r is right there. And so that's just going to be 36 plus 36, or 72 is r squared. So r is the square root of 72. Now, do you notice that we have a square root that is not a perfect square root? When that's the case, you want to reduce down as far as you can. Since 72 is 36 times 2, 36 is the largest square root, or perfect square, I'm sorry, that is in 72, and so we can make that 6 square root of 2. Okay? So now we know every side. Now let's think about what else we know. If we just had that triangle back in 4.1, when we were doing right triangle trig, this is our adjacent, this is our opposite, this is our hypotenuse. We can set up our 6 trig functions using that very tools that we learned in 4.1. We can also use the fact that our adjacent is always going to be our x value, our opposite is always going to be our y value, our hypotenuse is always that r. Now, we can use SOHCAHTOA and the things we've learned there. We can use the fact, this new information, that the sine, the cosine is x over r, and the tangent is y over x. That still lines up perfectly with your SOHCAHTOA, so you can do it either way, and it will work out perfect. So, let's set them up. Now, I want the reduced version of a fraction. I do not want any decimals. I want those exact values. So don't enter those square roots into a calculator. Just give me the 6 square root of 2 and that sort of thing. If we use the sine, that's going to be y over r, or opposite over hypotenuse, which is going to be 6 over 6 square root of 2. Now, that reduces down. Both of the 6's can cancel, which is 1 over square root of 2. And when rationalized, that's square root of 2 over 2. Now let's go to our cosine. Cosine is x over r, which is 6 over 6 square root of 2, or if we did it using SOHCAHTOA, adjacent over hypotenuse. You'll notice that's exactly what we got for the sine, and we still get square root of 2 over 2. And then finally, y over x. This is, oh, I'm sorry. we forgot something in the cosine. The cosine, the x is negative, so make sure that our cosine is negative. Anytime we are in that second quadrant, your x is negative and your y is positive. Sorry about that. And then our tangent is going to be our y value of 6 over our x value of negative 6, which is negative 1. In the second quadrant and in the fourth quadrant, the tangent will always give you a negative value. Now they asked us to find these 6 trig functions. So far we have found 3. Let me write down the other 3. We've got cosecant, secant, and cotangent. So we're just going to take and flip over the sine, the cosine, and the tangent respectively. Now you may flip over whatever version you like. For the sine, I think I think this one's a good version to flip over. And so we get square root of 2 over 1, or square root of 2. For the cosine, I think this one's a good one to flip over. But if you flip over any of them and reduce them, you'll get the same thing. That's negative square root of 2 over 1, which is negative square root of 2. And the cotangent, if you flip negative 1, the reciprocal of negative 1 is still negative 1. So each time you do this, you're going to just set up your triangle, connect the point to the origin, connect the point to the x-axis, label your triangle, do SOHCAHTOA, do your 6 trig functions like normal. So in problem 33, it says to find the exact values of the 5 remaining trig functions, given that the tangent is 2, the sine is, and the cosine is positive. Now what does that really mean? Well, that means that since the sine is y over r, that tells me that the y value is positive. And since cosine is x over r, that tells me that the x value has to be positive. So what we can do is, just like in the first example, we know that in the first quadrant, both the x and y is positive. So if we look at our tangent and make that a fraction, tangent is y over x, so we can just use the point 1, 2. So let's do just what we did for the last problem. So we're going to go over 1 and up 2. We're going to draw our point. First thing we're going to do is connect it to the origin, then connect it to the y-axis. Here's our theta. We know our x value was 1, our y value was 2. And now let's find our hypotenuse. So I know that r squared is x squared plus y squared. So r squared is 1 plus 4, or 5. So r is always positive. It's going to be the square root of 5. Now, if we label our triangle, this is our adjacent. This is our opposite. Here is our hypotenuse. You can do it exactly like you did for any other trig function. So I'm going to write down my sine, my cosine, and my tangent, which I already know, but I'll put it there. And then I'm going to write next to it my cosecant, my secant, and my cotangent. So what would sine be? Well, sine is going to be your y over r, or you can do opposite over hypotenuse, however you want to do it. So that's going to be 2 over square root of 5. And rationalize, that's 2 square root of 5 over 5. For a cosine, that's going to be adjacent over hypotenuse, x over r, which is 1 over the square root of 5, which is square root of 5 over 5. Now we already have tangent was 2. And now let's use our reciprocal functions. Cosecant, let's flip over, I think this one's probably the easiest to flip. So that's square root of 5 over 2. And then cosine, let's flip over that one. That's square root of 5 over 1, which is just square root of 5. And the flip of our tangent, remember, if you need another number, just put it over 1, and then take the reciprocal. So the main thing to remember here, remember the x is our cosine, or x over r is our cosine. The y over r is our sine. This quadrant's positive, positive, so the cosine and sine are both positive. This quadrant is negative, positive, so the cosine is negative, but the sine is positive. The third quadrant is negative, negative. Both the sine and cosine are negative there. And the fourth quadrant is positive, negative. Since the x value is positive, but the cosine is positive, but the sine is negative. In this quadrant and this quadrant, the tangent are both negatives. And in this quadrant and this quadrant, the tangents are both positive. Just a little thought thinking about that thing. Okay? So that is your main objectives, and this is what your homework is going to look like for that first part in 4.3. So please make sure you watch that Ed puzzle tonight, and you finish up this homework by tomorrow. Okay?